Hi, we are the Robotic Knights. We're all from Plainview and we're 11 years old. My name is Ayush and one of my hobbies is to play with different kinds of gadgets. I joined FLL because I like to experiment with Legos.
Hi, I am Arnav, and in my free time, I like to play chess, read, and also play the baritone and the piano. I joined FLL because I like building Legos.
Hi, my name is Drew. Wait. I like to play trombone and also like to play baseball. I joined FLL because I was interested in coding the robot to do certain tasks.
Hi, my name is Pradyun and some of my hobbies are to play tennis, soccer, and also play French horn and piano. I joined FLL because I like to code and learn new things.
Hi, my name is Rishan. One of my hobbies is to paint. I joined FLL because I wanted to learn more about real-world problems and engineering.
Our FLL project is about the last mile. It's 111. It stands for one box, one van, one house. We're able to research about the last mile by watching helpful webinars, going on reliable websites, and also going around the neighborhood and looking for recycle bins. We also spoke to a few people in the industry to get feedback.
Our problem has many parts. Each item comes in a different package. Delivery workers do not have time to rest and have to keep delivering packages house to house with no rest.
Here are some more problems we researched about in the last mile. The first is social issues. This is where workers are paid less. They drive too much, which results in them not having enough time for breaks. The second will be pollution. When there are so many trucks driving to people's houses, it creates pollution, which is not good for our environment. The third will be safety in our neighborhood. When there are so many trucks driving to your neighborhood, one might crash into the other, which is not safe.
Our solution is to add one step to the sorting center. Instead of randomly placing items on shelves, we can sort the items for each house or neighborhood. With this, we can also add one truck for each neighborhood. We can also inherit USPS's idea where there is one post office for each town. This is called the 111.
Some benefits include less safety and ease for drivers, convenience for customers, reduced pollution and materials on the economy. There's less driving work because drivers have to deliver less packages to each house. That leads to more time, which means longer breaks and more productivity. Then there's less traffic because there are less vans on the road. It's convenient for customers because there's only one van coming to our house per day, and we have less waste to manage from secondary packaging. There's reduced pollution because we're using less cardboard, so there are less trees cut. We could also use less plastics in secondary packaging, and we could reduce the amount of gas emitted by trucks. Lastly, there's a huge profit from less materials spent, and it's efficient since only one package needs to be delivered instead of several packages in the current system.
We added big wheels in the back of our robot to increase the balance. We also only added...
Wait. It's Q&A.
You had to say that was the end of our innovation problem.
Yeah, somebody, I think we
Yeah,
Rishan, you were going to say that.
We skipped the Q&A.
Yeah, so Rishan said that is the end of our innovation presentation. Now, so questions? Name 3 websites. I don't know what you said about the websites. Name 3 websites you consulted.
We used the FLL website, and then we used...
What is the website?
It's
First Inspires, I think.
.org. And
also when we're...
firstinspires.org, and what is the other FLL website?
FirstLegoLeague.org.
That's right.
Also,
.com or .org?
.org.
Okay.
I also use New York Times for a lot of my research.
Good.
Did you interview any experts?
No.
You did.
Yes.
You did. And
Oh,
talk to anybody?
We
One.
spoke
Two.
Two.
we
Yeah.
spoke to a person who is in the packaging industry and another person.
And the person who used to work in?
Not really,
Who
like,
are
he's not
still, used to work in Amazon.
That's right.
That's
Yes.
what
Yeah,
he
that's what they're going to ask that one.
That's the answer. Okay.
Robot design? Any more
No,
questions?
we're asking questions. We have some time.
question answer.
Wait, any more questions?
What was the most frustrating part of doing this?
When we started testing the robot and the robot kept failing and failing, and then after when we were recording, our robot kept failing even when the code was all right.
Mostly because of like the wobbling wheels.
Wait, I have a question, but it's a Q&A about the innovation
Could be anything.
problem. Like,
Yeah, I think.
but
Yeah.
it's not. It's not
Yeah,
about,
we
it's
didn't
not
talk about
the
robot design, so
robot.
yeah, you might not
It's not
explain.
about the robot though.
Yeah.
So then we have to talk
No.
about like the hardest thing for the innovation
Yeah.
problem.
Yeah,
think so.
because
I
there
think-
was robot design.
Yeah, I think the hardest thing for me was finding the websites to use because many websites talked about the last mile, but it didn't really talk much about the problems and what the workers go through.
Why did you pick the last mile?
We picked the last mile because we thought it had the most points and more details to add.
It was also the one that was like closest to us because the last mile problems are something that could happen in the everyday lifestyle.
Very good.
Very good answers.
Did you also research on other miles, and did you feel that there was a problem which also could have been solved?
We researched all of the miles, but decided that last mile had many problems, and we came up with a solution for the problem. So we chose the last mile.
Okay, let's go into robot design.
Now we're gonna start robot design.
We added big wheels in the back of our robot to increase balance. We also decided to only add 2 attachments because of the missions that we made with our robot.
We realized that we only needed 2 attachments. These are the forklift and the arm. We found out that the forklift and the arm collapsed. This means that a state of the robot is very compact. This is good because then we have space to put other stuff.
There is a problem when doing the unused capacity task. The back attachment part was too high, so the container would fall over instead of getting pushed. We fixed this by putting the back attachment a little bit lower, so now the robot can push accurately and we could complete the unused capacity task.
The robot has a low base, which makes the base stronger, which makes the robot do its missions easily.
We added frames to trap the wires inside the robot, which keeps it neat and organized. It also helps to attach and balance the hub and other accessories, and it makes it compact. Then we developed a system that uses the gyro built-in sensor's yaw angle to help the robot determine which angles and directions it can travel to. This helps the robot to move much more accurately, and it helps it to correct itself when it goes off track. That was the end of our robot design.
Do you have any questions?
What was the biggest challenge when you're making the robot?
I'd say it was very difficult to come up with a robot at first, but then after that it was mostly trouble with the wheels.
We also had to make a big decision if we go with the stock robot that they gave us or make our own robot.
And also, when we made our robot, we weren't sure what tasks we were doing, which made it difficult. But then later, we made a chart to choose which tasks were the easiest for us. Then we built our robot that way.
Did you take any help when building the robot from any websites or any other study material or anything like that?
We watched a few robotics videos from like Mr. Hino, and we decided that a robot design would work very good for us.
We also used the Spike Prime app a little bit too, so it could give us helpful tips.
We used videos to see which attachments we should use.
And the videos helped us to see what attachments were best for what tasks.
What are the challenges you face, like, when doing the programming?
I think, well, it's like finding a way where the robot can go through, because there's one spot on the map where a robot can barely fit into, so we had to try multiple times to fix the code so that the robot can actually go in that path.
Do you think you could have? No, actually, this is just design. Sorry, I was talking into mission. Okay, no, I'll pass. You can ask her.
Why did you pick Spike programming? I believe we can use Python also, right? Like, why did you pick Spike?
We chose Spike instead of EV3 because
EV3,
it had newer features that were not in EV3, such as a built-in gyro sensor.
If you were to do the robot, what? Sorry, you were
There's
answering.
also
Something else?
Spike Prime is also much easier to use.
So if you were to build the robot again, what changes would you make to the design?
A little more compact. Our robot is pretty big. Like Drew said, it's very hard to fit in some places on the mat.
And also, I would probably focus more on making the wheels like really stable, because sometimes the wheels were wobbly when we were doing missions.
Also, the forklift was not that stable, and it kept falling off the stand.
And it was a lot of weight on the robot due to extra parts, so we would probably remove some parts that were not needed.
And we would probably try to make the base a little bit smaller because it doesn't have to be that big.
Which was the most interesting mission, according to you? And why?
I say the most interesting. I think probably the home delivery was the most interesting mission because it's a very small area to get to the door, but we managed to code there to get to it.
I think the air job mission is also pretty interesting. There's a lot to do.
I think that the unload plane is like a really interesting mission because like you have to push a lever for something to come out of it. I think that's a cool concept.
I think the switch lever was really interesting because you had to put the package inside the circle, and at the same time you had to switch it.
It was Switch Engine and Cargo Connect.
I thought the unload ship was really cool because you had to know the exact amount of power to push the arm to unload the ship.
Instead of 2.5 minutes, if you had 5 minutes, which other missions would you try?
I would probably try to do the sorting centers and maybe put the green and blue package into the green and blue circles to get more points.
I would also try to do the second part of the platooning trucks mission to get us a little bit more points.
I think we could do train trucks with our current equipment, so I would try that.
I think maybe we could do the accident avoidance task.
Did you experiment with other attachments before you decided to pick up only those two attachments which you decided?
We mostly built our robot after deciding which missions because we wanted to base our attachments on the missions that we decided, so we wouldn't waste time and it would be easier.
Okay, we'll go into the core values. How did you show the core values?
We discovered how to use the robot parts, also the parts. Also how to build a strong, balanced base. We learned how shipping works for online purchases.
We innovated by using frames to keep the wires in and to organize the robot. Then we used a gyro straight program that uses the built-in gyro sensor yaw angle to help the robot keep track of movements and make them more accurate.
Impact. By researching about last mile problems with transportation, we suggested a solution to help the efficiency, reducing waste and pollution. The one box, one van, and one house. Who knows, maybe our solution might be used one day.
We included everyone into the robot building. First, we split into 2 groups. In the 2 groups, we all had to create our own robot. After we were all done, we discussed which parts should go on our main robot. After this, we put our brains together and found out way more than we thought.
Discovery. One way we teamwork. One way we use teamwork in our FLL Cargo Connect project is we spent more than 70 hours together building and working on the robot. Another way we use teamwork in our FLL Cargo Connect project is we all contributed into building the robot, coding, and solving occurring problems in the that's happening.
We also had a lot of fun while doing this. For example, I had a lot of fun when we first started and we were building the Legos for the missions so that we could start to program.
We also had a lot of humor during this process.
Also, while coding and building the robot,
That concludes our core values reflection.